ServCity's 6 partners, Nissan, Hitachi, University of Nottingham, TRL, SPD Automotive and Connected Places Catapult, combined cutting-edge thinking, domain expertise and a collaborative approach to tackle the barriers to deploying autonomous vehicles in cities. From simulation to advanced urban road trials, all underpinned by user experience and behaviour research. ServCity is creating a blueprint for how autonomous vehicles can become an everyday experience for everyone, everywhere. The Smart Mobility Living Labs cooperative infrastructure links the entire process of getting from A to B, from specialist on-street cameras to its control room to the AV itself, allowing for real-time data sharing, analysis, and enhanced situational awareness along the route. The infrastructure maps and understands the environment, from vulnerable road users to vehicles and road features, analyzes factors such as behavior, position, or speed, and then communicates this to the vehicle, enabling it to maneuver more effectively. Thanks to this real-time connection, the AV has the foresight to literally see around corners. Up ahead, out of the vehicle's line of sight, the on-street cameras log a bus at a stop. The AV is then informed to smoothly change lanes, far earlier than a human driver might otherwise do. This stream of information, coupled with learning and development across the trials, replicates that sense of familiarity with recurring behaviours and road features typically held by a local driver. Of course, developing a human-like driving style goes beyond just knowing the highway code. It's about understanding the unspoken culture of the other road users. For example, if a roundabout is clear to the right, the expectation is that the car with right-of-way will not slow down or stop, but continue smoothly onward. To avoid road user confusion, the AV needed to be taught to match this expectation. Over repeated trials, the ServCity vehicle was able to develop these behaviours, ensuring a seamless experience alongside human drivers. Successful integration means all road users smoothly interacting and understanding one another, including pedestrians. A UK-first behavioural study by the University of Nottingham explored pedestrian reactions to vehicles with no visible driver, and how best to communicate and understand intent between these parties. For example, a vehicle-mounted external human-machine interface is being used here to help bridge the gap of understanding between pedestrians and the vehicle. Beyond the research itself, the team is recording and sharing the methodology used in order to help accelerate the scale and adoption of these technologies to the automotive supplier base. Through modelling of citizen needs and common road and route features, ServCity is reducing the need to replicate trials at future locations, with a scalability blueprint providing a road-ready framework for CAV deployment. The first of its kind, this model can help urban policymakers plan for future transport infrastructure and services, offering an improved user experience that is safe, intuitive and efficient. ServCity's findings will pave the way towards a future of mobility for everyone.
I'm Kazuhiro Doi, Corporate Vice President and leading the research division, global research in Nissan. The main challenge of the autonomous driving, fully autonomous driving, is the first thing is the safety, actually. Yeah, how safer we can drive in such a complicated environment. Yeah, especially in the case of the London, the driving environment are very, complex. We have a roundabout, and our drivers is rather aggressive. We can see lots of the cut-in situations. Yeah, because of the London bus is stopping a lot, and other road users have to avoid such a kind of situations. Yeah, and so in that sense, that we have many, like I say, risky situations for the driving. But the question is how we can handle such a kind of complex situation with an agile manner. But if we want to move the vehicle agile, sometimes the passengers are not comfortable yet. So that's why we have to be very smoothly handle the situations to provide more comfort to the customers. Yeah, there's a tons of the challenges, but the London is one of the most difficult case, I think. Okay, in case of the Nissan, we have mainly 3 locations to test the autonomous driving. And one is Japan, Yokohama. It's my hometown. And the other is Silicon Valley. we have many AI engineers in the Silicon Valley office, and they are leading the research for such a kind of, the more intelligence. And in case of London, we are tackling the European dedicated environment. So as a global location for the autonomous driving research, I have three main locations. The first one is Yokohama in Japan, and Silicon Valley in United States, and London in UK. Nissan announced Ambition 2030, and in that program, AD-ADAS is one of the important pillars to realize the cleaner, safer, and more inclusive society. And one of the big expectations to the autonomous driving is to contribute the more accessible society. So, and the mobility in the city and the mobility in the countryside are very different. Maybe in the city like London, we have some mobility issues like traffic jam, and also some traffic accident, and also some the exhaust gas. But in the countryside, the most important or most difficult issue is the accessibilities. Yeah, especially in the case of the countryside, we have more and more senior peoples which cannot drive by themselves. So, and I expect the autonomous driving to provide more accessibility for their daily life, to move freely. As for the Nissan autonomous driving, we have two expectations to the autonomous driving. For the passenger car, we make the car more safer and more convenient. And for the autonomous driving, like a level 4, so-called level 4, we expect the more accessibility to the society, so-called robotaxi type of things. Okay, so actually I joined Nissan about 30 years ago. And at that time, I thought, the EV will come, and finally autonomous driving will come. But now it's really the timing to realize all the stuff. And from now, what I want to see is how those technologies deployed in the world. So now, every country is, taking more and more electric vehicle to realize a cleaner society. And I'm sure that, for sure that, the autonomous driving or unmanned vehicle will come soon to be deployed in the society. And then, but still, I believe that, the passenger vehicle driven by the human drivers still remains. We need that. And I want to enjoy the driving, actually. But, autonomous driving, or fully autonomous driving, like unmanned vehicle, will contribute to society with a different way. And that is also another, I can say, not say fun, but expectation for me for the future society.
My name is David Moss, and I'm the Senior Vice President for Research and Development in the region covering Africa, Middle East, India, Europe, and Oceania. ServCity is an autonomous mobility research project, and this is where we take an advanced autonomous vehicle coupled with artificial intelligence and then bring it into what is a complex urban environment like we have here in Greenwich in London. But one thing that makes this project really unique is the vehicle also talks to the road. This means we use feedback from 270 cameras, which is located in the environment, and we can actually beam information to the vehicle about traffic conditions so that the vehicle can actually change lanes automatically to enable smooth traffic flow. ServCity is a consortium-based project. In fact, there are 6 partners, but Nissan, as an automotive manufacturer, have brought a vehicle to this, which is the LEAF, the first mass EV which is produced in our Sunderland manufacturing facility. But what we've done is we've taken that LEAF and using a dedicated team of engineers at our UK research centre, we have basically adapted this vehicle with advanced sensors together with a lot of AI technology to enable us to take on something as complicated as what we have here in London on the ServCity project. But it's not the first time we've done this. This is building on the experience we did a few years ago on something called a human drive, which enabled us to develop a vehicle that drove autonomously from our R&D centre in Cranfield 230 miles up towards our Sunderland plant. Autonomous drive has many benefits for the customers. Now, one of those is about how do we improve vehicle safety, or should I say road safety? Because when you have an autonomous vehicle with a number of sensors like the vehicle you can see here, the vehicle is able to basically monitor the environment 360 degrees around the vehicle 100% of the time. It doesn't get distracted, and by doing so, it means that we can actually help to improve road traffic safety. But also, when we do projects like this in London with ServCity, where we're able to actually improve the vehicle flow, of course, we can improve congestion. And that is one of the things that cripples a lot of our cities today. But finally, the last benefit is something we call accessible mobility. Because today, not everybody can drive a vehicle. So what we can see is if we can get a vehicle that is fully autonomous, then we are able to offer mobility to customers today or people today who actually maybe are not able to drive a vehicle in such a complex environment by themselves. One thing I love about R&D, and especially research, is the ability for us to really push the boundaries of what mobility can do today. And it's only through doing research like we've done here in London is that we can really drive the potential for the vehicle and its ability to manage more and more complex environments to the greater good of the environment and the people who drive them.